Mathematics. Today I'll be discussing regarding of mathematics, how to solve the mathematical formulas and everything. And this is especially using for trigonometric functions. See, an angle is formed by joining the end points of two arc lines. See, there are two lines is there. One will be horizontal, another one will be inclined. That you have in a 30-degree angle. See, this is inside. The side you measure from is called initial side. This is the terminal side. Look at here. The side you measure is called terminal side. There are inside and next to having the terminal side. In between having a angle. This is a counterclockwise rotation. See, you have in a clockwise. Clockwise, clock always moving. There are 12, 12 to 1, 1 to 3. This like will be moving in the clockwise. This is a counterclockwise rotation. This counterclockwise rotation, see here, mm, you have in a clockwise rotation. And next, angle measured counterclockwise are given position sign. Angle measured the clockwise are given the negative sign. See, this is the negative angle and positive angle. See, when you look, that will be counterclockwise is the positive angle and clockwise is the negative angle. See, it is Greek to me. It is customary to use the small letter in the Greek alphabet to symbolize angle of measurement. This is alpha, beta, gamma, theta, and phi. This is the delta. See, we can use a coordinate system with angle by putting the initial side along the positive x-axis with the vertex of the origin. See here, there are two lines is there. This is the initial side and this is the terminal side. Some angle, maybe 30-degree, maybe 60-degree, maybe 90-degree. The theta is positive. See, this is the theta is negative. The first quadrant plus into plus. This is the positive quadrant. This is the negative quadrant. See, we say the angle lies whether a quadrant the terminal side lie in. See here, same. This is the quadrant 2 angle. This is the quadrant 4th angle. See, this is the quadrant 1, quadrant 2, and quadrant 3rd and quadrant 4th. If the terminal side along on the axis called the quadrantal triangle. This is calling about quadrantal triangle. See, we will using two different units to measure when talking about the angle, degrees and radians. See, if we start the initial side, go of all the way around in a counterclockwise direction, we have in 360-degree. This 360-degree, see, you have started here 0 to 360-degree, and next you are probably already familiar with the right angle measure 1 by 4th of the way around 90-degree. Let's talk about degrees first. You are probably already somewhat familiar with the degrees. See, this is 0 to 90-degree, and this is if we went 1 by 4th of the way in a clockwise direction, the angle would measure minus 90-degree. See here, what is the measure of this angle? See, you look it here. First, you have started from 0-degree, and then 45-degree, 90-degree, then 270-degree. Then you have this like you'll be adding the degrees. You have measuring. See here, the theta is equal to 360 plus 45 and 360 minus 360 plus 45. When the clockwise and anti-clockwise direction is there, see here, you could measure in the negative direction. There are many way express the given angle. Whichever way you express it, it it is still quadrant first angle since the terminal side is the quadrant 1. Co-terminal angles are angles that have the same terminal side. 62 degree, 422 degree and 298 are all co-terminal because graphed they don't all look the same. See here next, this is the 62-degree angle here. Since 360 is all the way around the circle, 422 degree would be all the way around circle plus another 62 degree. See here, angle alpha, beta co-terminal if and only if there is a integer case such that m is equal to beta equals m alpha plus k 360 degree. See here, if the angle is not exactly to the next degree, it can be expressed as a decimal. Decimal means this is the decimal. See in degrees, minutes and seconds. Please look at here. First you have in a theta will be measured degrees and then it will be minutes and then it will be seconds. See here, first you have in a degrees, minutes and seconds. 1 minute is equal to 60 seconds and 1 degree is equal to 60 minutes. The convert the decimal from the conversion fractions. There are the fraction where the numerator equals to denominator but two different units. Put unit on top, you want to convert the foot unit on bottom, you want to get the reader. See here, let's convert the second minute 30 degree 30 seconds, 1 minute by 60. Again, you have in a 60 seconds, that will be 0.5 seconds. See here, 25 degree, 48 seconds and minutes. Just you have newtons. Let's convert the conversion fraction. See here, how can using the conversion fraction, since the angle of sight first you have 45 degree. See if you can guess the size of those angle in degrees. 45 degree, 60 degree, 30 degree, 120 degree, 180 degree, 90 degree and 150 degree and 135 degree. Types of angle are classified based on their measure. Between 0 to 90 age, between 0 to 90 degree acute, and between 90 to 120, 180 degree, 90 degree and 180 degree. See here, here's some common angle between 0 to 360 degree in standard position. 0 to 360 degree. See here, first you have started from here in 0, 0 to 90, 90 to 180, 180 to 270, 270 to 0 degree. See here, one concept is very important in everybody, in every students. Keep in the quadrant will be moving in the anti-clockwise direction in the 360 degree. First you started from 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330. Still you have dividing in 4 quadrants. These 4 quadrants in 0 to 90, 90 to 180, 180 to 270, 270 to 0. See, in every minutes you want to change. You want to do some uh, in first you have in a degree, seconds and minutes. That conversion, this is very important in the um, first division. I'll be completed. I'll be discussing about the uh, radians, minutes and seconds. Next I'll be move for, that is very important, radian measure. See here, first will be area. See any curvature length, any arc length. I'll be take it in any arc length to measure using the arc length, area, radian measure. See another way to measure the angle is using what is called radians. To take any curvature portion, you take any n number of things, that is either in you take in the cartoons, there are varieties of cartoons is there. That cartoons you have in a curvature portion, you want to measure. When you go to the scientific application, you want to measure the curvature portion. See, given a circle of radius r with the vertex of an angle center of the circle, if the arc length formed the intercepting the circle with the sides of the angle is the same length as radius r, the angle measure 1 radian. See, that is very, very important here. This is the initial side, this is the terminal side. Always the terminal side you have in 0 degree, then will be 30 degree, then will be 45 degree, then will be 90 degree, then will be 120 degree, then will be 135 degree, then will be 180 degree. This like will be variation. See here, you have in your initial side to terminal side, the angle is 30 degree. The angle measure 1 radian. Arc length is also r. See here, just I write it here. Just I go to draw the lines. Draw the lines. This is the horizontal line. This is the vertical line. And this is the angle measure. This is the angle degree. See, next I will move for arc length S of a circle is found with the following formula. S is equal to R alpha. This is S is equal to R alpha. S means arc length, R means radius, alpha means measure of angle. Important angle measure must be in radians to use the formula. Find the arc length if we have circle with a radius of 3 meters, center angle of 0.52 radian. See here, that is very, very important to the arc length. This is the alpha equals 0.52. Arc length to find the block. See, S is equal to 3 alpha. S is equal to 3 into 0.52 into 1.56. See, we need to conversion of degree to radian. S is equal to alpha A. Please look at here. That will be, let's start with the arc length formula. 2 phi r is equal to r alpha. See here, r get cancelled in the both the sides. Remaining alpha is equal to phi. Next, alpha is equal to phi. 2 phi radian is equal to 360 degree. 2 phi radians is equal to 360 degree. Convert 30 degree to radian using the conversion fraction. 30 degree into 2 phi radian by 360. Phi radian is equal to 180. 30 degree into 2 phi radian by 360. 2 1 ja to 2 ja cancel to get the values for 180 degree. 5 by 60, 5 by 6 radians 0.52. Can leave with the 5 or use the 5 button on the your calculator for the decimal. Convert 5 by 3 radians to degree using the conversion fraction. 5 by 3 radians, 180 degree by 5 radians. See here, again just I look it in the initial stage. This is 0 to 30, same that this is here, look it here. Phi is equal to 180 degree. This phi symbol will be indication for the this phi is indicated the 180 degree. Phi into 180 into 2, 360 degree. 360 by 6 you have in 360 by 6, 6 1 ja 6 6 ja. This is 30 degree. Then 5 by 4 45 degree. 5 by 3 60 degree. Next you'll be add 2 pi by 3 120 degree. 3 pi by 4 135 degree. 5 into 5 by 6 150 degree. 210 is equal to 7 5 by 6 225. 5 into 5 by 4 240 degree. 4 into 5 by 2. This is the next. I will move for, see here, this is very, very important. You have a measure the angle. When you go for the multiple choice question, is asking how much radian will be indicated pi by 2. 90 degree, 30 degree, 60 degree, 120 degree. 90 degree will be indication. Area of a sector of a circle Alpha or the formula for the area of a sector of a circle shown in read here derived in your textbook. It is A is equal to 1 by 2 r square alpha. Again, alpha must be radians, so if it is in degree, you must convert the radian to the use formula. Find the area of the sector if the radius 3 feet equal and alpha equals 50 degree. Convert to the radians, alpha equal 50 degree. 50 degree into 5 radian denominated by 180 degree. Degree get cancelled, only decimal points is available. 5 radians by 180 is equal to 0.873 radians. See, linear velocity, next time we go for the linear velocity. This linear velocity, circular motion, this circular motion always calculation by using the omega. Omega equals alpha by t. When something is rotating, we can measure how fast the angle is changing, called angular speed. This is generally designated by Greek letter omega. See, where, for example, where measured circular motion, you have a soft, you have an automobile soft, that soft you want to rotate. You have any circular soft. Suppose you have a circular soft. This circular soft, you just put the effort, then you will be angular movement. This angular movement is calling about omega. That omega will be calling about the rotating. We can measure the past angle of changing in angular speed. That angular speed you want to measure, that is calling about, that is the twisting movement, that is the twisting torque. You want to put effort to move the vehicle. For example, just you have a bus. That bus you have a very heavy height of the road. You want to move. You have a heavy torque is there, then you will be move very easily. You want simultaneously torque with speed, both can adjusting, then will be moving. See, omega is the angular, alpha must be radian, t means the time. We can also compute linear speed upon the object that is rotating. Think of placing a mark on wheel and then keeping track how far the mark travels. It would travel around the circle, so it makes sense to use arc length as per the distance. See, this is the circle. Just look at here. This is the circle. This is also wheel. Just to think about wheel. This wheel you move to this position to this position, this position to this position, this position. This like you have continuously rotating the whole wheel in the one round. You want to twisting movement. That twisting movement is calling about torque. The mark traveled the distance of r alpha, since s is equal to r alpha. Speed is equal to distance per time. Speed to measure by using the distance per time. Linear speed is equal to v, that s by t. Angular omega is equal to alpha by t. So we have angular speed omega and linear speed v. We can get another formula for linear speed by doing some substituting. See here, s is equal to alpha into r. V, s by t. V is equal to alpha by r into t. Alpha is equal to omega by t. This is angular speed formula, but solved for alpha. V is equal to omega, t get cancelled. That linear speed is equal to r into omega. We want to linear speed, we will be use V is equal to r into omega. See here, the denominator is there in the t. T get cancelled, remaining values is there. Angular speed is equal to r into omega. See, 3 revolution per second into 25 radian. See here, just since we don't have feel for how fast inches per second in a car, let's convert into miles per hour using the conversion fraction. And the, how to conversion fraction using for in any measuring. Suppose you have using the pressure unit in Pascal. 1 Pascal is equal to 1 into 10 to the power 5 Newton for mm square or Newton for meter square. This will be conversion factor. This conversion factor V is equal to 282.7 inch per second. This inch per second you converted to miles per minute. 282.7 inch per second. 1 feet is equal to 12 inch. 1 feet is equal to, this is the 1 feet. How much this length is there in the 1 feet? You have in a 12 inches. V is equal to 16.1. The trigonometric functions. First, let's look. Next, I will go for everybody should be. I will be go for explanation for the trigonometric functions. Since cosine, tangent, since sine, cosine, and tangent, they are abbreviated using there are first three letters: sine, cosine, and tangents. Let's look an angle alpha, standard position whose terminal side contains the point x and y. This is the x comma y. This is the r radius. Let r be the distance from the region. See, r equals to square root of x square plus y square. R can be found using the distance formula. The three basic trigonometric functions can be see this is very important. Please look at here, everybody. This is the horizontal axis x, this is the vertical axis y, but this angle will be, this is the y. See, sine alpha is equal to y by r. See, cos alpha is equal to x by r. Tan alpha is equal to y by x. There are three more trigonometric functions. There are called the reciprocal function because they are reciprocals of the first three functions. Sin alpha is equal to y by r, cosine alpha is equal to r by y, cos alpha is equal to x by r. Cos alpha is equal to x by r, secant alpha is equal to r by x, tan alpha is equal to y by x, tangent. See here, based on the fact that there are three trigonometric functions are reciprocals of three basic one, they are called reciprocal identities. See, this is the reciprocal identities. What is meaning by cos cosec alpha is equal to 1 by sin alpha, secant alpha is equal to 1 by cos alpha, cot alpha is equal to 1 by tan alpha. This is just to have change the place. Sin alpha is equal to 1 by cosec alpha and cos alpha is equal to 1 by secant alpha and tan alpha is equal to 1 by cot alpha. Find the values of the six trigonometric functions of the angle alpha if standard position who have terminal side passes through the point. See here, this is the example. See, sin alpha is equal to y by r. Y is equal to minus 5. R is equal to this one. This is the r values. 4 square plus minus into 5 square. That is the square root of 41. This is the r values. Next I'll be calculated x by r. That is cos alpha. X is equal to values how much? 4. R is equal to square root of 41. Tan alpha is equal to y by x. 5 by 4 minus 5 by 4. See, often the preferred way to leave the answer is with a rationalized denominator. An angle whose terminal side on the axis is called the quadrantal angle. A 90-degree angle is a quadrantal angle. To find the trigonometric functions of 90 degree, choose a point on the terminal side. This is the 0, 0 to 90, 0 to 1. Since sin alpha is equal to y by r, 1 by 1 is equal to 1. Cos alpha is equal to x by r. Tan alpha is equal to y by x equals to 1 by 0. Undefined. Cosec alpha is equal to r by y equals to 1 by 1 is equal to 1. Second alpha equals r by x 1 by 0 undefined. See here, to fill the following table, quadrantal angle is the graph below. Start with 0 degree. Figure out the answer. Then click the mouse to see if you are right. See here, first I'll be started here. 1 sin alpha, cos alpha, tan alpha, cot alpha, cosec alpha, sec alpha, and cot alpha. See, this is the sine, cos, tan, cosec, sec, and cot. This is the different angle to measure 0 to 90, 90 to 180, 180 to 270, 270 to 360. Sin alpha is equal to y by r, cos alpha is equal to x by r, tan alpha is equal to y by x. Next I'll be r by y, r by x. See here, undefined. See all the trigonometric function alpha if quadrant both first both the x and y value is positive. See here in the first quadrant in the x-axis, horizontal axis and y-axis, both are positive. The second quadrant, the horizontal axis negative, vertical axis positive. X is that values will be represented here minus into plus. Next third quadrant in minus into minus. Again fourth quadrant minus into plus. Okay, this like will be quadrant will be dividing. Second quadrant. See, look at the first quadrant, sine, cosine, and tangent. Other quadrant reciprocal function will have the same sign of as the original. Since the flipping a function over does not change its sign, we can see from this that any trigonometric function that required the x value will then have a negative sign on it. See here, in the quadrant third, x is negative, y is negative. The r is always positive. So if we have either x or y with the hypothesis, we will get the negative. If we have both x and y, the negative with cancel. See, in the quadrant fourth, x is positive and y is negative. Sine is minus, cos is plus, tan is minus. So any functions using y will be negative. See here, all the trigonometry in the first quadrant, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. All the trigonometry function is positive. Sine is plus, cos is minus, tan is minus. Sine is minus, cos is minus, tan is plus. Sine is minus, cos is plus, tan is minus. To help the remember those signs, we look at what trigonometric functions are positive to each quadrant. See here, this is all the trigonometric function is positive. Only sine function is positive, tan function is positive, and cos function. This is remembering in your mind. ASTC, ASTC. Just remembering in the abbreviation in your mind. ASTC. What is the answer? ASTC. See here, A is a I mean to help the remember start. This is all. See here, computing the values trigonometry functions is acute angles using special triangles 45 degree, 45 degree, 90 degree. See, this is 1 into 1. This is root 2. 45, 45, 90 degree angles, 90 degree triangles. The sides are in the ratio of 1 minus 1 minus root 2. This means I can build a triangle with those. those lengths